Hey guys! Okay, today we're going to do lesson 5, the zero and identity matrix. So go ahead and get your notes pulled out here. I'm going to fill these in for you, and then you've got some practice and homework, and I did have an extra sheet today. Since I'm not here, I wanted to give you guys a little bit more practice with the sub. So there is a zero matrix, and it operates the same way the number 0 does in addition, where if you add 0 to anything, you get the number back itself. So let's kind of talk that out. Any number added to 0 in regular math gives the original number back, right? 4 plus 0 is 4. Okay? So for that reason, 0 is called the identity element for addition. Okay, so 0 is the identity element for addition because when I add 0 to any number, it gives the original number back. It doesn't change anything. Okay, in matrix multiplication or matrix addition, any matrix in which all entries are 0 is called a zero matrix. And it works the same way as 0 does. Okay? Any matrix added to the 0 matrix gives the original matrix back. Okay? So for that reason, the 0 matrix is the identity matrix for matrix addition. Okay? And you have to size your 0 matrix to match whatever you're adding it to. So this is a 1 by 3. So of course, we would be adding this to another 1 by 3. A 0 matrix can be a 2 by 2, or it can be a 4 by 3, whatever. You size the 0 matrix to be able to add to whatever you need. Because remember, with addition, unlike yesterday, with addition, the dimensions to be exactly the same. So of course, if we're adding A to the 0 matrix, then we add the elements that are corresponding. So it would be 3 plus 0, negative 5 plus 0, 2 plus 0, and 1 plus 0. And so our final answer is 3, negative 5, 2, and 1. Okay, so that is called the identity because we got back what we originally started with. Okay, let's look at example 2. There are many dimensions that a 0 matrix can have. I already showed you a few up there. The dimensions of the 0 matrix that we add must equal the dimensions of the original matrix. The condition that makes a 0 matrix is all elements are 0. Okay. So which of the following 0 matrices can be added to matrix A, which is a 2 by 3 matrix? We're going to need a 2 by 3 identity matrix to add to it. Okay, it has to match. Example 3, fill in the missing entries for the addition problem below. So in row 1, column 1, I have a 3. I have to add something to it to get to 0, so I'm going to have a negative 3. I'm going to put a 2 in row 1, column 2, so when I add it to negative 2, I get 0. I'm going to put a 5 in row 1, column 3 for the same reason. And down below, the same thing. Something plus 2 equals 0, that's got to be negative 2. 15 plus negative 15 equals 0. And 1 plus negative 1 equals 0. You might have a question on the quiz Monday that looks like that. All right. What happens when we multiply by a zero matrix? What happens when we multiply by a zero matrix? Well, if you did anything times a zero matrix, you're going to get a zero matrix. So the product is a zero matrix. So when we multiply by zero, it's not an identity anymore because my answer is always zero. It's not the original. Okay. What dimensions would we use to get a zero matrix with the same dimensions as the original? Okay, we have to think about that a little bit. So if our original matrix was row times columns, okay, and we wanted to multiply it by something, and we want to get the same dimensions out as the original. So we want our answer to be row times columns. What has to go in here? That's what this question is asking. Well, I need my last, this matrix has to have a C for rows because remember, the two inside numbers have to be the same. And if I want it to look like this, it's going to have to be column by column. So that would be the answer. That's what we would multiply by to get the same thing that we had before. So that's a square matrix. All right, let's go ahead and look at the back here. So now we're going to talk about the identity element for multiplication. Okay. So in regular math, if you multiply any number by a 1, you get the same thing. Okay, you get the original back. 4 times 1 is 4. 7 times 1 is 7. Okay, so for that reason, 1 is called the identity of multiplication. I don't actually call it that. That's what these notes wanted me to write. You'll normally hear it referred to as the multiplicative identity. Multiplicative identity. Okay. There's an additive identity and a multiplicative identity. Additive identity is 0. Multiplicative identity is 1. Okay. So we can create an identity matrix for multiplication. So it's not going to be the zeros anymore. It's going to be some version of 1 so that we can multiply a matrix to its identity to get the same matrix back. Okay, so in regular math, we would multiply anything times 1. But because 1 is a 1 by 1 matrix only, we've got to have a way to make a 1 in different dimensions. Okay, we've got to have a way to make a 1 in 2 dimensions or really any dimension that we need. Okay, so that's what this definition of identity matrix is. This identity matrix is a form of the number 1. Okay, and we're going to make it fit our problem. So an identity matrix I is always a square matrix. That's important. Where the number of rows is equal to the number of columns, such that the entries along the main diagonal, and we learned main diagonal a couple days ago, are 1s, and all other entries are 0s. Okay, so if you're multiplying and you need a 2 in the first number, row times column, you need those middle numbers to be 2, you're going to use this identity matrix. 1's in the main diagonal, everything else is 0. If you need a 3 for rows for the second matrix, you're going to make a 3 by 3. And they're going to have ones down the main diagonal and all the rest zeros. Okay. If we needed it to be a 4 to multiply with, we would go 1, so 1 0 0 0, 0 1 0 0. So I'm filling in this diagonal with ones. Okay, everything else is going to be zeros. So 0 0 1 0 and 0 0 0 1. That's a 4 by 4 identity matrix. Okay. Say, for example, if we had this original matrix, this is a 2 by 2. This is an original. And we're multiplying by 1. So this would be like 1. We would need it to be another 2 by 2 because, again, we need these numbers to match. And since the identity matrix has to be a square, it's going to be a 2 by 2. So when we do this multiplication, you can put it in your calculator to check it. You lay this column over this. So 2 times 1 is 2 plus negative 3 times 0. So that goes in the first cell. So 2 plus 0 is 2. Then you lay row row 2, column 1. 4 times 1 plus 1 times 0, so that's 4. Row 2, column 2. 4 times 0 plus 1 times 1. And so if you look, the product is the same thing as the original. And so this is a fancy form of 1. It's an identity matrix. There is only one multiplicative identity value for real numbers, but there are many identity matrices. And that is because the identity matrix used depends on the dimensions of the original matrix. Okay. So let's look at example 2. If we start with a 2 by 3 matrix and we're going to do A times I is the identity matrix, what size do we need? Well, we need our dimensions. We need these middle numbers to match, so we're going to use a 3 by 3. So they call that I3. Okay. Now, what about if we do I times A? So what if we multiply it from this other side? If we multiply it from this other side, it's going to need to be a 2 by 2. Okay, so this is the original. So if we go A times I, it's going to be I3. But if we go I times A, it's going to be I2. 2 by 2 matrix, identity matrix. All right. Remember, in our calculator, we definitely get different answers. Multiplication is not commutative, and we figured that out on Wednesday. Multiplication, let's say matrix multiplication, is not commutative, meaning order matters. Okay? All right. So the products for example 2, what are the dimensions of those products? Well, in the first multiplication with the 3's, it's a 2 by 3. And in the second multiplication by times I2, it's also a 2 by 3. And that makes sense because remember, when you multiply by to an identity matrix, you're going to get the original back every time. So it should be a 2 by 3. That's not going to change. So they're the same, yes. And that's because we are really multiplying by 1. So the result, the product, is the same regardless of order. Now that does not always happen, and we saw that on Wednesday. When we change the order, sometimes it's even undefined in one way versus in one order versus another. So, all right. So let's just quickly look at what you guys have left to do. So these are your notes. What I want you to do is, of course, you'll see those. Let's go ahead and let me talk you through this since I'm not here. You have a practice sheet that you'll do now. I left the key to this with Miss Stone. So you'll answer these. You'll check it. You can use your calculator to put in A, B, C, D, and E. But remember, you'll have to, this is the identity matrix I, and then this 0 is the 0 matrix. So this is the identity matrix and the 0 matrix. And it just, I don't guess you really need to do much here because you have I's and O's. But I would like for you to write out what I would look like in this problem so I can see that you understand how to do the dimensions. Okay? Same with O. So write out how those matrices would look. So go ahead and write the problem out and put the answer. Okay? These are really straightforward. Okay? On the back here is a fun little, one of those little crazy word puzzles. And it says, examine the matrix equations involving 0 and identity matrices. And you can see some of these are being multiplied to 1 and some of these are being multiplied to 0. And you're just going to fill in the missing values with letters. Okay, you're just going to fill those letters in and you're going to make something down here. All right. This is what you're going to turn in for your homework. And then the last thing, let me go find it just one second. I have an extra sheet that I got made for you guys. Okay. So this is your third assignment for today. This is matrix multiplication worksheet. So you're given a matrix A and a matrix B. This is not for the calculator because they're letter values. Miss Stone has this sheet. This is an extra sheet that she'll hand you. And you're just going to answer if it's defined or not. And if it is defined, perform the operation. Okay? You're going to do that for 1 and 2. Oops. My light just turned off. Number 3. And then on the back, sorry. 4, 5, 6, and 7. Okay. This worksheet includes some problems with identity matrices in them. As you can see, these are identity matrices. Okay? All right. Well, thank you guys for your attention, and I will see you on Tuesday. Bye-bye.